Okay, so among the many vectors, there are some important vectors. One type is called the standard unit vectors. Okay, so every vector can be written as a linear combination of these. In R2, we have two standard unit vectors. These are, of course, unit vectors, meaning their length is 1. And these are called I and j. Again, you may have seen this in like a class like a trigonometry or something. Okay, I is the vector that goes in the positive x direction, that's 1, 0. And j is the unit vector that goes in the y direction, that's 0, 1, right? So it's very clear. I mean, the vectors are, again, I'm running kind of slow here. The vectors are, let's see, maybe I'll use this. It's so slow here. That's this vector. Why is this not a vector here? That's the vector, and this is a vector. Okay. All right. So what I am trying to say is that this first one is I, and the second one is j. Right. Now, if you have a vector, let's say this vector is the vector I'm thinking about is 2, 3. Well, you can write this as a combination, more technically linear combination of I and j, because 2, 3 is the same thing as 2i plus 3j. And you will see vectors written in both of these formats. Okay, I personally like to use these angle brackets as opposed to I and j for multiple reasons, which I'm not going to go into right now. But, and if, you know, many times books, especially books where they're typing in the old-fashioned way, they would use 2i plus 3j because I guess it's easier to input 2i and 3j as opposed to these angle brackets. In three-dimensional space, oh, by the way, I haven't drawn for you three-dimensional space. You really should, okay? And you should practice drawing in three-dimensional space. Fortunately, I have these tools that would allow me to draw straight lines with certain angles. Every time you draw R3 or a space, okay, we have a convention we follow. Just like the x-axis is always the horizontal axis and the vertical line is called the y-axis, right? In three-dimensional space, the one that comes out in our direction is called x. The one that goes to the right is the y-axis, and the z-axis goes up in the vertical direction. This is called the right-hand orientation. The whole idea is, I don't know if you can see me here. Here's my face. You see that little thing here, my face. And let's see where is it. Yeah, this is my right hand, okay? And if you just kind of use your right hand and try to wrap your fingers around the, from x-axis to the y-axis, positive x-axis, and then around to 90 degrees to the positive y-axis, right? And then your thumb is, you know, facing up, right? As opposed to this way, you know, thumbs down, it's thumbs up as your fingers, your four fingers here, wrap around from X to the Y direction, you know, Z goes up. And so this is called the right hand orientation. And this is the standard orientation we use for three-dimensional space. Anyway, so in this space, we have the three standard unit vectors. I is 1, 0, 0, of course. J is 0, 1, 0. And K is 0, 0, 1. And so again, every linear, every vector in three-dimensional space can be expressed as a linear combination of I, J, and K. Right? For instance, if you have a vector 3, 2, 3, then that's 3i plus 2j plus 3k, obviously. Okay. All right, so let's try to finish this up. Hopefully, section 1 is not being too difficult, right? This is pretty much all the basics of vectors. Let's practice drawing these, though. Okay, in fact, should I do this? Yeah, I think so. Okay. You can practice drawing these. And that's not going to work for me. All right, let me go ahead and try to do this again. All right, so I am going to draw the X, Y, and Z components. All right, so I'm going to save some time here. I will draw this and I will be right back. All right, so let's practice how to sketch these. All right, so the first vector is 1, 5, 4. So where is that? All right, so you can take, let's see if I can get that. 1 unit to the right, to the X direction, and you have 1, 2, 3, 4, 5. And try to draw a bunch of parallelograms, right? So maybe it helps you to draw with a lighter color. What I normally do is something like this. That's not a very nice line here. Let's try to do a better job. And let's use a lighter color. I hope you can see this. So this line should be parallel to the y-axis, and this line should be parallel to the x-axis, right? Okay, so that point of the intersection is the point 150, right? And then from here you go up 4 units up, and just assume it's 4 units, even though I'm not doing this exactly, precisely. That's like 1, 2, 3, 4. All right, and so now connect this point. Let's see if I can use a blue arrow from 0, 0, 0 to this point 154. And the graph will look something like this, okay? And that's the vector, 1, 5, 4. Make sense? That's not what I was going to draw, right? So this is 1, 5, 4. Okay, and so make it look like it's in 3 dimensions, even though you're drawing on your piece of paper or on your screen, which is definitely 2-dimensional. All right. So what helps is these light auxiliary lines that would make it look like it's in 3 dimensions. How about negative ones? Negative components are kind of tricky. -3, 1, 2, 3. It's sorry, that's the wrong way, right? So x direction, -1, 2, 3. And so this is -3. And then you go 2 units to the in the negative x direction, negative y direction. That's this. Okay. So this point here is the point -2, -3, 0. And then you go 1 unit up here. So in terms of my auxiliary lines, if I draw these lines here, first I go -3, and then go -2, and this should be parallel. So the graph would be something like that, right? And then you go 1 unit up. Right? Without the auxiliary lines, it's really hard to figure out where the graph is going. So, and this is still hard to, to picture, right? And so often, if I have to draw a picture like this, I normally go ahead and write down the components as well. All right, I have been using these cool, arrow and straight line tools on my computer. But if I have to do everything freehand, like most of you do, then I would have to do it this way. Okay, last one, -2, 0, -3. You may want to pause this video and then see if you can draw this. Okay, you can do that, just pause. And then when you think you have drawn this correctly, you can come back. Ready, set, go. Okay, so -2, you go -2, that's 2 units away from the positive x direction. Y is 0, so I don't have to go this way or this way, right? I don't have to do that. But then I have to go -3, so let's go ahead and draw I said completely freehand. Okay, so what I would do is I would draw a line perpendicular to perpendicular to the bottom of the page, which is the same direction as the z-axis, and I'm supposed to go -3 units here. Okay, so it ends up like this arrow here, and I should probably erase all my unnecessary drawings here, like this and that. Oh, Now I just deleted the Z axis, which is not good. For some reason, this is really taking a long time for me to graph this. So it's not that way. All right, and in order to make sure that we have a vector, you may want to put a little arrow here too. Okay, and just having these little lines will help you, so see which direction. Because if you didn't have any of these other lines, you don't know where this arrow is going. I mean, is that going down or is that coming up from the XY plane, and so on. All right, so this is pretty much your introduction in section 2.1 of 2 and 3 dimensional vectors. Okay, I hope it's being clear, and then we will go into a lot more interesting things about vectors and vector spaces in the sections to come. All right, so until next time, I hope you have a great day. Have a good day and see you next time.